Light is an electromagnetic wave. This visual shows a beam of light propagating towards you. The electric field shown as red vector oscillates perpendicular to the light beam's direction. The magnetic field shown as blue vector's direction oscillates perpendicular to both the light beam and the electric field's direction. The polarization state of a light beam is defined by its electric field, therefore, the magnetic field will not be displayed. Imagine pulling a screen at a fixed location in the beam's path and watching the tip of the electric field vector versus time as shown by the yellow ball. In this example, the electric field oscillates up and down in a line, and the beam polarization state is called linear.
Unpolarized light can undergo polarization by reflection of non-metallic surfaces. The extent to which polarization occurs is dependent upon the angle at which the light approaches the surface and upon the material that the surface is made of. The angle at which the reflected part is completely polarized is called Brewster's angle. Sir David Brewster in 1892 found that the maximum polarization of the reflected ray occurs when the reflected ray is perpendicular to the refracted ray. This is called the Brewster's law. The given diagram shows the Brewster's angle condition, which is r is equals to 90 minus theta b. Here theta b is the Brewster's angle and r is the angle of refraction. Also, tan theta b is equals to mu2 upon mu1, where mu2 and mu1 are the refractive indices of the two mediums.
So now we are going to discuss the setup of Brewster angle experiment. The setup consists of a laser emitting diode, two polarizers, a collimating slit, degree plate, D-lens, aperture bracket, analyzing polarizer, light sensor and rotary motion sensor. The spectrophotometer is mounted on a rotating arm. The D-lens should be mounted on the upper plate of degree plate, and the 90 degrees mark should be aligned to 180 degrees of the lower disc initially. The polarizers, collimating slit, D-lens and aperture bracket should be aligned in such a way that the only 90% of light enters into light sensor so that it does not damage the light sensor. The light sensor and rotary motion sensor are connected to Pasco interface system, which is connected to a laptop which has Pasco capstone software. We can note down the angle and light intensity percentage in the Pasco capstone software.
After the setup is complete, set the gain on 0 to 100 on the light sensor. Click on start and adjust the polarizer so that you get the maximum intensity without exceeding 90%. And before taking the readings, ensure that the room lights are out as they add to the background lights. Now start the experiment by clicking on start. Initially, the disc is set at the 90 degree mark. For each subsequent reading, we decrease the angle by 10 degrees till we reach the 30 degree mark. Now for each reading, we move the spectrometer arm so that we get the maximum intensity. After this, we place the analyzing polarizer in its place and then we record the angle and the reflected light intensities. We type the intensities and angle into the table and then we get the ratio of the incident and reflected light intensities. Repeat the experiment for a lower step of 2 degrees for the range of angles for which the intensities were minimum. Perform the entire experiment 3 to 4 times to minimize the error.
After filling the table, a graph is to be plotted for every iteration with fit curves as some even degree polynomials as shown in the figure.
Now the final Brewster's angle is the average of the minima of the fit curves. The error occurred is the standard deviation of these minima. Errors that may be involved are gross errors like wrongly taking the data, instrumental errors like wrong construction, environmental errors like background light, and random errors.